of the season. You know what I mean. All right, so here we go. We want to talk about circles today. You guys ready? Really try and help me out today so I don't have to talk quite so loud. So I think the easiest thing to do is I want to start with a bunch of formulas. I think that's the easiest way for us to approach things, I think. So, first of all, trying to decide if I want to actually draw a circle or I'm going to cheat. Shall I cheat? Is that a circle? That's an ellipse. Yeah, that's not going to work for me. Should I make a bunch of circles? I don't know. All right. So we're going to try it this way. So first formula, if I have a circle, and in that circle, I have two lines or two chords connected at the same angle. Okay, so this is our first option. This angle at X, the arc directly across from it is 2 times the angle. So 2x. Okay, formula number 1. That's a silly circle, but formula number 2. If I have 2 lines that are tangent to the circle, tangent means it touches the circle in one spot. If this is X and this arc on the inside is Y, then X plus Y equals 180. You do remember some of this.
I remember looking at the circles on the
Okay.
Okay,
that's good. We've seen a circle before. All right, so now, this time, let's say we have one tangent and one chord, but it goes outside the circle. So let's call it from, here's a chord, but it goes outside along with a tangent. And so I really have 3 things going on here. I have X in my little angle. I have Y in my small close arc. And I'm going to have Z on my outside arc. Okay, I'm going to use those as my formula. So the way this works is I have, let's see here, 2X plus Y equals Z. Huh? Yep, Z's brought in now. Now, this also works if both of them, and I'm going to do the exact same one. I'm going to go right underneath here. Let's say I have a circle, and both of them are chords that extend outside to the angle. So neither is tangent. So let's say I come out here and here. Follows the exact same thing. If I have X, Y, and Z, 2X plus Y equals Z. So it works for either situation. Couple more formulas I want to give you before we really start talking about how to apply things. The next one I want to mention is if I have a circle and I have a line directly tangent to that and a chord that goes across. So I have this angle that's right here. See this angle that goes from my tangent line to my chord extended line or my secant line. This is X. This is Y for that side. So this X refers to that angle right there. And the formula for this one is 2X plus Y equals 360. And one last one. I have a circle. In my circle, I have 2 chords that intersect. First of all, if I put x right here at this angle from geometry class, that means this one right here is also x, right? Why? What's the word, the official geometry word? Vertical angles, thank you. Yes, vertical angles. Okay, so, and let's make this side y, this arc on this side y, and the arc on this side z. My formula for this one is that 2x equals y plus z. Excuse me. All right, so we're going to use some of these formulas. I want to start, before I get into some other things, because we also have angles to talk about, I want to do some examples using each one of these, okay? So let's start with example number 1. I have a circle. Let's say on my circle I have two, start with tangent lines. And pretend that's tangent and it touches it. Let's say this arc right here is 106 degrees. I want to know what this angle is. It is. How do you know that? Yeah, this angle is double that one. Or they've got to equal what? Not double. No, no. Yes, thank you. Yes. So, in this case, this one, these two have to add together. This equals 74. Or x plus 106 equals 180. So, x equals 74. Okay, so what does that mean that this side would be? Okay, you can do it that way, or, okay, so we know that x equals 74. What if I wanted to know from here to here what that side is? What is y? Okay, how, okay. Because it's on the outside, just wanted to point out that it also fits another thing. Once you found that angle, if you look at one of the rules we talked about, right, if you take 2x plus y, that equals z, right? Same thing as if you took 360 and subtracted, but it's another one of those rules. So if I take 2 of my x's, which is 74 times 2, right, and then add y, I get this side. This is my y in the formula, right? In the formula I gave you in the picture? Okay. Let's try it. We'll just do another example. Never mind. Okay, example number 2. Circle. Let's go, how about this one? Say I have these 2, and let's make let's say that this side is 120. What is x? Correct. X equals 60. So when the angle is inside the circle, it is half of what its opposite arc is. Okay? That one makes sense. Okay. Example number 3. Let's try another one. Say I have a circle. And let's go with tangent line here and a chord going this way. This angle right here, let's call 55 is that angle, and I want to know what is this arc. So we take 2 times 55. Technically, I'm going to put it in the formula I gave you, plus x equals 360. All right, 2 times 55 is 110. Subtract 110 to the other side, and x equals 250. Okay? I just want to make sure I'm always plugging them into the formula so you guys can see. So what if I gave you, same picture, I'm going to move it down a little bit, but this time I'm going to give you the big arc. You got to find the little angle. So we're going to change it up a little bit. So let's say I have the circle. I have my line, tangent. I have my chord. And let's say that this side we'll call 200 and, let's say 205. I want to know what this angle is. So we want to find x. So technically putting in the formula, that means I have 2x because I don't know what that angle is, plus 205 equals 360. I'm going to subtract 205 the other side, so I have 2x equals 155. Divide both sides by 2. And x equals, okay. All right, let's see, what other one can I throw at you? Let's do example number 4. Again, using those same. Let's get a little bit tougher one, maybe. Say I have a circle. Let's go with a tangent line here. And let's go with a tangent line to here. And I'm going to tell you that this side is 180. This angle is 52. I want you to find the inside arc. We're going to plug it into our formula. I know because I made it 180, yeah. But correct. Right. Okay, so if we put it into our formula, again, this formula, when you had the 3 angles, it was technically 2 times 52 plus x equals 180. Right? So 2 times 52 is 104 plus x equals 180. Subtract 104 to the other side, and x equals 76. All right? So I want you to be able to use those formulas and which one it applies to. Do we have any questions on those? I know some of you are listening, some of you aren't. I just want to make sure we're good. Okay. So then let's go to some other things that don't need formulas. It just needs your logic. Here's example number 5. Let's say I have a circle. There is my circle. Inside my circle, I have several different chords. So I have one that's the diameter directly across. Let's go with another one here. Let me get some letters up here real quick. Let's say this is A, B, C, D, E, and we'll call the center F. And if I said, let's go with this arc is, I don't know, let's say 43. And let's say this one over here is 40. Find what do I want to find? Let's find DFE. How do you know? Correct. Okay. Very good. So we're taking 180 and we're subtracting 43 plus 40, right? Or we're subtracting the other two. And we get 97. Okay? Example number 6. Let's make it harder. Let's get a little more logic going. Again, if I have a circle, and my circle has a radius, go straight down, and that radius intersects a chord perpendicularly right here. And then I also have, let's go from here to here. So if I tell you that the radius is 23, and that this length right here is, let's say 11, I want you to find x. So, in order to do this, you first have to finish your triangle, right? That's right. So we need to find this piece right here to begin with. And you use the Pythagorean theorem to do so. All right, so we're going to start with a squared, or 11 squared, plus this unknown, so I'm going to call that b. It's my unknown, b squared, equals 23 squared. You got b to be 2.8? No. Oh, you did the other one? Okay, let me get my calculator. So right here, we're going to take 121 plus b squared equals 529. Subtract that to the other side. B equals 20.2. I'll go 20.2. So if B is 20.2, so this part right here is 20.2, how do I figure out x? Right, so 23 minus our B value of 20.2 equals 2.8. Because again, if you look at this picture, if this is our radius, which is 23, this is also our radius, which is 23. Okay, so you have a couple problems on the worksheet that you do that with too. Find that little piece, subtract it from your radius. Okay, any questions? All right. Let me get you this worksheet so you guys can get started. I'm sure most of you are going to have this